You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your IT Fundamentals certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. In this episode, we compare two major forms of data storage: flat files and relational databases. While both are used to hold and access information, their structure, capabilities, and intended use cases differ significantly. Flat files are simple and often limited in scope, while relational databases are complex, structured systems designed to manage larger and more interactive data environments. You will learn how to recognize these differences and understand how they relate to questions on the Information Technology Fundamentals Plus exam. This topic is part of Domain 5 of the Information Technology Fundamentals Plus exam, focusing on database structures. You may encounter questions that ask you to identify whether a description applies to a flat file or a relational database. You might also be asked which option is best suited for a specific business scenario. The goal is not to build or configure databases, but to recognize the basic structures, terms, and examples that define each type. Conceptual clarity is the main objective for this topic. A flat file is a simple, text-based data file that stores information without any built-in relational structure. These files often use the .txt or .csv formats, where each row represents a record, and columns are separated by commas or tabs. A flat file consists of only one table or document and does not link to other files or data sources. It is linear, straightforward, and easy to open with basic tools like a text editor or spreadsheet application. Flat files are widely used due to their simplicity. The key characteristics of flat files include their lack of relationships between datasets. Each file stands alone and contains only the data within its rows and columns. Flat files are easy to read, edit, and create, making them useful for quick tasks or temporary storage. However, they are best suited for simple projects or one-time data transfers rather than long-term data management. Their simplicity makes them ideal for situations where complex structure is not needed. A relational database, by contrast, stores data in multiple related tables. Each table is designed to hold data about a specific subject, such as customers, orders, or inventory. These tables are linked by unique keys that establish relationships across the database. A relational database supports complex queries, structured data, and multi-user environments. It can manage large amounts of data across different entities while keeping the relationships between them intact. Relational databases are defined by several structural characteristics. Tables are made up of rows, which are also called records, and columns, which are also known as fields. Each field contains a specific type of data, like a name or date. One of the key principles in relational databases is normalization, which means organizing data in a way that avoids redundancy. By separating related data into distinct tables and linking them, relational systems maintain accuracy and scalability. One of the most important concepts in a relational database is the primary key. A primary key is a unique identifier for each record in a table. It ensures that no two records are exactly alike. Common examples include a customer ID, product number, or employee code. The primary key allows the database to efficiently locate and manage individual records. It also serves as a reference point when connecting one table to another through a relationship. A foreign key is another critical concept in relational databases. It is a field in one table that connects to the primary key of another table. This relationship allows the database to maintain consistency and link related information. For example, an order table might include a customer ID as a foreign key that references the customer table. This ensures that every order is associated with a valid customer and helps prevent errors and duplication in the data. There are many advantages to using a relational database. These systems are efficient for handling large volumes of data, especially when multiple users need to access or update information at the same time. Relational databases support advanced searches, filters, and logical queries that allow users to quickly find specific data. They also maintain strong data integrity through built-in rules and constraints. These features make relational databases ideal for business systems and mission-critical applications. Flat files, while useful in many cases, have limitations that make them less suitable for complex or long-term use. They are not designed for simultaneous access by multiple users. If two people try to edit a flat file at the same time, the file may become corrupted. Flat files are also difficult to scale because they lack built-in structure for linking datasets. In addition, they do not offer native support for queries, so finding information often requires manual searching or external tools. When deciding whether to use a flat file or a relational database, the context matters. Flat files are appropriate for simple tasks such as temporary data storage, small configuration settings, or exporting data from one system to another. They are also useful for log files or lightweight data sharing. Relational databases, on the other hand, are preferred for complex business applications, interactive websites, and environments where multiple users need access to structured, secure, and searchable information. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. To better understand flat files, it helps to look at practical examples. One common use is exporting data from a spreadsheet to a .csv file. This flat file can then be shared or imported into another system. Configuration files in software often use simple text formats to store settings, such as user preferences or default values. Log files, which track user activity or system events, are also often stored as flat files. These uses take advantage of the flat file's simplicity and portability. Examples of relational database use are found in almost every modern application. Online stores use relational databases to track products, customer accounts, and orders. Human resources systems manage employee records, benefits, and payroll with interconnected tables. Ticketing platforms for events or customer service track requests, users, and resolution status. These systems rely on relational databases because they require structured data, search functionality, and secure multi-user access. The Information Technology Fundamentals Plus exam may ask you to recognize the type of system being described based on how data is organized. If a description refers to a single table with columns and rows, it points to a flat file. If the description involves multiple tables linked by IDs or related records across entities, it refers to a relational database. Understanding how each system is structured will help you correctly identify them when presented with example scenarios. One of the key distinctions between the two systems is how they handle access by multiple users. Relational databases are designed for concurrency, which means multiple users can view and modify data at the same time without causing errors. This is possible because of built-in transaction handling and user controls. Flat files, in contrast, may become corrupted or unreliable if more than one user attempts to edit the file at the same time. This limitation is a critical factor when choosing between the two. Security and access control are also significantly different between flat files and relational databases. Relational systems can define permissions by user roles, limiting who can view or change specific data. They also support features like encryption and user authentication. Flat files, unless managed by external systems, offer limited built-in security. They can be opened or modified by anyone with file access, making them less suitable for sensitive or regulated data environments. Several terms may appear in exam questions related to this topic. These include table, which refers to a set of related data, and "record," which means a single row within a table. Field refers to an individual column that holds one type of data. The primary key identifies each record uniquely, while the foreign key connects data between tables. Other important terms include flat file, relational database, and normalization, which refers to organizing data efficiently in relational systems. You will not be asked to perform technical tasks such as creating tables, mapping relationships, or writing SQL commands. The exam does not test your ability to normalize data or design a relational schema. Instead, it focuses on recognition. You may be shown descriptions or scenarios and asked to choose whether they best represent a flat file or a relational database. These are high-level comparisons intended to support foundational knowledge, not advanced database skills. This topic matters for IT literacy because understanding how data is stored affects many parts of technology. Whether you are troubleshooting a system, planning a migration, or analyzing data, knowing whether you are working with a flat file or a relational database makes a difference. This knowledge applies across many disciplines in IT, including support, development, administration, and analysis. It also lays the groundwork for learning more advanced database concepts in future study. To summarize the key points, flat files are simple, single-table formats often used for small-scale, temporary, or export-related tasks. They are easy to manage, but limited in functionality. Relational databases use multiple linked tables, support large and complex datasets, and allow multiple users to access information securely and simultaneously. The Information Technology Fundamentals Plus exam will test your ability to distinguish between these systems based on how data is stored, accessed, and used. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.